Hello everyone, welcome to Physics Galaxy. Today I am with another problem of JEST 2026. The question states that consider a system of a large even number of hard identical particles combined within a length L in one dimension which is bounded by two reflecting hard boundaries. At time t equals to 0, half of these particles have velocity plus v and the other half has velocity minus v distributed randomly among them. Assuming that all collisions are elastic, which one of the following sentences is correct? So, here are four options. First option is the velocity distribution changes later from the initial distribution, but it never becomes the Maxwell distribution. Second option is the velocity distribution of the system becomes Maxwell distribution within the time t less than L by v. The velocity distribution of the system becomes Maxwell's distribution at the time t nearly equals to L by v. The velocity distribution of the system remains unchanged in all future times. So here it is said that here are a system of a large even number. Suppose even number, so we may consider that the number of particles is 2n. From here, at time t equals to 0, half of the particles have velocity plus v. So, n particles with plus v velocity and other n particles with minus v velocity. Okay. Now the collisions, all collisions are elastic. So we know that in elastic collisions both momentum and kinetic energy of the particles will be conserved. Suppose there are two particles m1 and m2. Suppose the first particles with mass m1 and initial velocity u1 collides with m2 mass and initial velocity u2. After collision, the velocity is v1 and the velocity of the second particle is v2. So, momentum will be m1 u1 plus m2 u2 equals to m1 v1 plus m2 v2. So the momentum is conserved as well as the kinetic energy is also conserved for elastic collision. So this will give half m1 u1 square plus half m2 u2 square equals to half m1 v1 square plus half m2 v2 square. Okay. So momentum and kinetic energy both are conserved for elastic collision. And also we know that in elastic collisions of between two particles, the velocity will exchange with each other. So when n particles collides with n particles, so velocity will exchange among these particles. So now n particles will have plus v velocity and the other n particles will be minus v velocity, as well as the conditions is given here. So our velocity distribution will be same for future times, as all the collisions are elastic collisions. So in option 4, the velocity distribution of the system remains unchanged as it is elastic collision, and for elastic collisions velocity swipes between each other, between two particles, so n particles also exchanges their velocity after elastic collision, and the velocity distribution will remain unchanged. So our option 4 is the correct answer. Thank you.